Hello there. So lately I have been learning to program in assembly language. And there was a friend of mine who said that she would be interested in learning too, which is why I'm making this video. And with any luck, this could also turn into a series for learning assembly language. So before I start, I want to motivate why I want to learn assembly programming. So recently I saw this talk by Jonathan Blow entitled Preventing the Collapse of Civilization. Jonathan is a very prolific video game designer and programmer, and also he is currently building a programming language for making video games. In this talk, he really motivated me to dig deeper into how computers really work. Um, not just the coding in high level programming languages, but also understanding how all of the stacks, all of the layers upon layers of software that we use every day, how everything works from the operating system level, from the programming language, the compiler level, all of that. So I want to at some point make a proof of concept operating system, just to prove myself that I understand how an operating system works. And as you may know, Linux was really created that way by Linus Torvalds, and in a way, I'm just trying to recreate what he did back in 1991. And if I want to make an operating system, then I had better really know how the computer works, how the CPU works, the instruction set, and how it has to interact with hardware. So that's my motivation. But broadly speaking, if you really want to understand how the computer works, then assembly language might be something to consider. In this series, what I'm going to cover is what is assembly. We're going to be using the NASEM assembler. And because most of the tutorials online about assembly programming are based on NASEM, and upon using it and another assembler, I found this one to be the easier to learn, or with a more agreeable syntax, I would say. Unfortunately, most of the tutorials online are based on the Linux platform. So in order to run the code examples associated with these tutorials, you're gonna need a Linux computer, either Ubuntu or Debian are the common ones. And because I'm using a Mac, I'm actually going to use Docker to get my Linux in there. So to emulate a Linux on my OS 10 computer, and for Mac users and also Windows users can use this. Also, I will demonstrate how to get your Docker set up and to have the Linux instance running on your computer. And then finally, hopefully we can get through all of that and run write a Hello World ASEM program. So let's get started. So what is ASEM? It is a very low-level programming language. The code looks kind of like this. Well, so here, or you can look at it as just this part. You can ignore this part with the codes. Here, you can ignore that. Just look at this. So the idea is you would write code in this format. The code in that format gets translated into these bits over here, which are the exact codes that your CPU is going to run. CPU, what is a CPU? Well, a CPU is a chip in your computer, It's the workhorse chip of your computer. So these codes actually get fed directly into the CPU, and these codes are instructions, I should say, derived from an instruction set which this CPU will directly understand. Most likely, if you have a standard computer, a laptop or desktop computer, you probably have the Intel chip, which is of the x86 family. The tutorial I'm gonna be basing on mostly, although not necessarily following it in the exact order, is this one. It's called asimtutor.com. It has a lot of code examples that are runnable in the Linux environment. So I will be using this, and then the assembler that is recommended by this tutorial is NASAM, and then their website looks like this. Again, I'm using a Mac OS, OS 10 in particular. So in order to get Linux on my computer, I have different options. I chose Docker because it seems to be a pretty cool new technology, making a lot of waves, and it's also extremely fast, which really impressed me. So Docker is what I chose to use to get a virtual Linux computer running inside of my Mac. So you can look at it as like you have a Mac computer here. Macs don't really look like this anymore. Okay, you have a Mac computer, and inside it's happily running OS X, but you kind of separated off a small section of your computer and say, hey, run me some Debian Linux. But the thing that's making that work is this crazy thing, or not crazy, but really amazing techno. By crazy, I mean amazingly sophisticated technology, or maybe crazy cool. This crazy cool technology called Docker that makes this happen, that allows you to run a Linux. Did I write Linux? But I meant Linux. Run a Linux inside of your OS 10 or Windows, because Docker also supports Windows now. Okay. So now, so for the rest of this episode, I'm gonna spend on getting set up. So let's go back to the Docker website and install the Docker application, which is a desktop application. So let's download desktop. And you do have to sign up, I believe, which I have. And I have also created an image for you to use. We'll look at that in just a bit. Okay, so first thing I'm gonna do is download Docker Desktop for Mac. If you use Windows, then get Docker Desktop for Windows. Okay, we have downloaded the Docker installer, and I'm opening it now. Okay, and now I'm gonna drag this docker.app into my applications folder. Okay, it's done. Now I actually need to run the Docker application like so. Or alternatively, you could go to your applications folder, find it, and double click on it. Mac OS 10 is verifying this application and is asking me, are you sure you want to open it? Yes, I am. It needs privileged access, so I need to type in my administrator password. And then now it's going. It also wants me to log in which I do have a login. If you don't have a Docker ID, you can go create one over here. You can click on this hub.docker.com and create a login. I have already created a login. If you haven't, then you need to do that. Okay, so I am logged in. I actually have two repositories. One of them is NASM Sandbox, which we will be using. But anyhow, once you loaded Docker, and Docker has to be running in order for you to execute the Docker commands. Okay, so you the way you tell if it's running is you see this little ship here is looking good or not. And currently it is. And now I can actually use Docker commands in my terminal. So if you open up a terminal in your computer, you can type Docker for a list of the commands. I decided to use Debian Linux because I heard it's one of the more lightweight Linux distributions. And Debian already has an image created for you on the Docker Hub. The Docker Hub is like a GitHub, except it's for Docker images, which what an image is basically a configuration for an entire computer. So the Debian image, for example, it contains everything that your computer needs to start and running in Debian Linux. And they released the Debian image so you can run it directly with Docker with just one command like this: Docker run Debian. So I'm going to run that, and you can run that yourself as well. And now it's already downloading that image, which is 50 megabytes. Okay, so it's done downloading the Debian image, and yeah, and if you do Docker images, you'll see Debian is listed as one of the images that you have access to. And you can already run this Debian Linux computer within of Docker right now. The way you do it is Docker run it Debian, I believe. And now you have a shell, and this is Linux now. How do you know this is Linux? Cat ECTOS release. Yeah, okay. So I can cat ETCOS release, and it says it's Debian Linux. So this shell is no longer my OS 10 computer. This is Linux now. And that's pretty amazing how fast it was able to get that running. Like, just look at it. That took like 1 second or so to sort of start an entire Linux computer from scratch, and to the point where you can start doing stuff in it. And that is quite impressive. If you're already using Debian and not OS 10, then you don't have to do any of this Docker business. And then all you have to do is install the software that's needed. So the software that you're gonna need, well, to follow along with the tutorial, are gonna be Nano, NASM, Bash, and GCC. Really, I mean, you should already have Bash actually. And if you want to use VI instead of Nano, that's fine too. So really the things you need are NASM and GCC. I have a image that I created that already have these things pre-installed. So if you're using Docker, you don't even have to install them yourself. And that image is called Airport YH NASM Sandbox. So if you do Docker run it again, Airport YH NASM Sandbox, then you'll get access to this guy. And that is 67 megabytes, so slightly more than 50 megabytes because I added some new stuff in there. And boom, now, so this computer now contains nasum, so you can type nasum and say, well, nasum wants a file, and it also has GCC. It has both of those programs pre-installed. Okay, so you can go ahead and use that command. Yeah, use this docker run. I'll explain IT in a moment. Docker run airport YH/nasum sandbox to get the nasum image installed, as well as the software you need for it installed. All right, let me take a step back and explain what Docker does and how Docker works. So again, you have your computer, which in my case is Mac OS 10. And inside of Mac OS 10, like Mac OS 10 has a bunch of different software running inside it, but one of them is Docker. And Docker, you can think of Docker is almost like its own operating system. Actually, more than one operating system. And within it, it is running these tiny computers too within it. And Docker calls these guys containers. So maybe I have container 1, and a container is like a mini computer that's running inside of Docker, running inside of OS 10. So you got each of these. So a container is like a virtual mini computer. It's a mini computer that's running in a in your computer. In your computer. It's a computer in your computer. How cool is that? A container, though, is based on some configuration that instructs Docker how to actually run this mini computer, and that is called an image. And an image, I'm gonna draw in maybe a different shape. Maybe an image is like a circle. So maybe an image is a, what is an image? An image is a computer configuration. So one image might be a Debian image. Another image might be an Ubuntu image. Another image might be a Windows image. So it configures all of the software that will run when it's sort of like realized into an instance, which is called a container. So when you run a command like docker run Debian, that is the image name. What docker run Debian does is say, can you instantiate a new container for me, one, using the Debian image. So let's say our A is the Debian image. Let's just pretend A is Debian. And we did docker run Debian. Then Docker says, okay, I'm gonna use this A image to spawn a new container, a new virtual computer in your computer, and that, let's say that is 1. And this one is gonna use A. And part of the magic of Docker is you can do that any number of times. So if you run another docker run Debian, you have a 2. You make another container now that is also using the image A, and that's allowed. Now, but Docker can also use B. Maybe B is the nasum sandbox that I created for you that has everything that Debian has. Actually, it's namespaced under my username. So you docker run airport YH/nasum sandbox, and then Docker will create another one, but this time it's using this image instead of the Debian image. So that's what Docker is doing underneath. So now, practically, the next thing we need to do to get everyone set up is map drives. So because every time you run a Docker instance, it'll spawn a brand new computer, a brand new mini computer based on that image. And the files that you're creating within the instance actually do not persist. So a simple way I found to allow it to persist files is map a directory on your host computer into the mini computer that's running inside of Docker, so that anytime you're accessing the files in Docker, you're also accessing the same files in your host computer. In my case, it's OS 10. So I decided to have my entire home directory mapped into my Docker containers, and that is done by using this Docker command with the V flag. So this is my directory that is on my Mac, and I do that colon the virtual directory I want created within my container. So with this, the container will have a /home directory, which maps to, it's like identical to my folder structure on my Mac in this directory here. And then I'm gonna use the IT flag, which just means run it interactively, so I can access that container using a terminal. I need to write the name of the container, which I forgot. So I use my NASM sandbox image, and now it has spawned a new container, and I'm running inside of the container. And in my home directory, I have a playground directory, which I have an ASM directory, which has all my ASM files. So that's how it works. So you can choose to have a home directory, or map your home directory, or just map some subdirectory you're gonna use for these ASM projects if you want to follow along. And then just map it so that the container can access it. Within the container, we're gonna use, or this is my plan anyway. You can deviate from my plan, but I decided to use the Nano text editor to edit my ASM files. I'm actually gonna go into my Linux directory. And I'm gonna open up the hello.asm file using the Nano text editor. And that's what a hello world file looks like. This is taken from lesson 2 of this tutorial here. I think it's, yeah, this code is taken from that. And then you can compile this code. How do you compile this code? Well, the tutorial tells you how to compile it. You first use the NASM command like so. Wait, did I call it hello world or hello? I call this one hello. So I'm gonna change it to hello. So again, nasm-f elf hello.asm. And then use the load command like so, except I have to change hello.o because the first step has actually created this binary file called hello.o, which is called an object file. And then I want to output a hello command, hello executable, which will then be executable by just typing its path. So now that guy prints out hello world, and that is your hello world. And that concludes sort of this video, just for the purpose of getting this set up. In the next tutorial, I'll actually get into the specifics of assembly programming. And yeah, if you want to follow along for the ride, I will see you next time.